parenthesis checking and string reversal. Today we are going to see one of the applications of stack in syntax parsing. So in compiler, whenever you compile your program, syntax checking is done. Means expression, whether the expression is correct or not. So whether all the syntax rules are followed in writing the program. So this syntax checking is done by the syntax analyzer. So for expression checking, there is a separate grammar. For many construct, for while loop, for if loop. So every construct in the programming language has got syntax. And that syntax checking is done by the syntax analyzer, or we call it as a parser. So you are going to see this aspect while you study in compiler construction course in third year. So in that course, you will be studying in detail how syntax analyzer or parser checks for the correctness of the program. So syntax analyzer or parser takes input of your program and it does the parsing. It does the syntax parsing. And in syntax parsing, this stack is used at the time of syntax checking. So it is just like a checking of the palindrome. Palindrome means you can see the string which when reverse will give you the same string, that is nothing but palindrome. Now I show you this is the palindrome. String ABA is the palindrome. Then only B is also palindrome, only A is also palindrome, because reverse of A is also A and reverse of B is also B. Then reverse of ABA is also ABA. So these three are the odd length palindromes. Let us see the even length palindromes. AA is even length palindrome because reverse of AA is also AA. Then BB is also palindrome because reverse of BB is also BB. Then ABBA is also palindrome because reverse of ABBA is also ABBA. Now let us see how stack can be used to check the given string is palindrome or not. Say for example, you want to check whether ABBA is palindrome or not. So first find out whether it's a even length or odd length. So here ABBA is the odd length. So take the mid. So mid is length is 4. So mid is 2. So push first two characters onto the stack as and when you read the character. So because this length is 4, push first two characters means push AB onto the stack. So when you read A, push it onto the stack. So A is pushed onto the stack. Then B is also pushed onto the stack. So after pushing AB onto the stack, then you read second half of the string. So first character of the second half of the string is B. So when you read B, compare B with the top of the stack. So this B is same as that of the top of the stack. So when current character, that is B, and top of the stack, that is B, are both same, when both are same, when match is found, then delete character from the stack, means pop from the stack, means B is removed from the stack. So the next character is A. So when you read next character in the second half, again try to compare this A with the top of the stack. So now top of the stack is A. Now this top of the stack is A. Now both are equal, the match is found. So when both are equal, again perform the pop operation from the stack. Now here no more characters is remaining in the input string and the stack is also empty. Stack is also empty. So when no more characters remains and stack is empty, then the given string is palindrome. Now let us see how we can check it for the odd length palindrome. So when you see the odd length palindrome, if it is more than 1, So any string with length 1 is a palindrome. So this is the string B of length 1. So this is already palindrome. So no need to check using stack. So this is the string of length 1, which is A. So this is also a palindrome. No need to use stack. But here it is an odd length string ABA. If you want to check it using palindrome, so first find out the length. So what is the length? Length is 3. So length is 3 means 3 divided by 2. So 3 divided by 2, we get it as 1.5. So 1.5 upper integer is 2. So this index, the second character is the middle character. The second character is the middle character, or 1.5 lowest integer of 1.5 is 1. So index at 1, character at index 1 is to be neglected. Character at index 1 is to be neglected, and this is the middle character. Character at index 1 is treated as the middle character, and all characters before middle character are pushed onto the stack, and all characters after middle character are compared and popped with the stack. So let us see A. So A is before the middle character, so A is pushed onto the stack. So A is pushed onto the stack. Then B is read. B is at index 1, so it is a middle character. So nothing is done with B. So it is neither pushed nor it is compared. So nothing is done with that B. Then after B, the character is A. Now when you read a second half character from the second half, now you read the character and compare this with the top of the stack. So this is also A, and top of the stack is also A. Then when match is found, then delete top character from the stack. Now when nothing remains to be read and when stack is empty, then the given string is odd length palindrome. So this is how using stack you can check in even length palindrome as well as odd length palindrome. Okay, so this is about checking the palindromes. The next one is backtracking. Backtracking is used in algorithms, so that you will be studying in next third year in the subject of computer algorithms. So what happens when you want to explore the states? When you want to explore the states, say for example, these are the states. When you want to search for a node, then see here. So when you visit this A, so it is pushed onto the stack. Then after A, you visit B, then B is pushed onto the stack. Then after B, this is C and this is D and this is E. Now after B, you visit D, then push D onto the stack. Now after D, already B is visited. Then next to visit is E. Now how can you come to E? So first nothing is there after D. So remove D from the stack. And then after that B is already visited. So remove B from the stack. After removing B from the stack, next adjacent node of B is E. Now put E onto the stack. Now here put E onto the stack. So A, B, so B is also visited. So B is also visited. So next adjacent of B is E. So E is inserted. So likewise. So we backtracked. So how can we backtrack? Only with the help of stack. So stack allows us to backtrack the state from forward state to backward state. So this is used in solving the 8 queens problem. So that you will study 4 queen problem or 8 queen problem, that you will study in backtracking chapter of computer algorithm, wherein we make use of stack. So as of now, you just remember that in exploring the states, in finding the node in the tree or graph, in exploring the nodes in the tree and graph, backtracking is used. Now, next very important application is expression evaluation. So expression can be represented in 3 different Polish notations. So there are 3 different Polish notations in which expression can be represented. So that is nothing but prefix notation, postfix notation, and infix notation. Now expression can be expressed in one of these 3 format, and using stack you can convert from one notation to another notation and vice versa. Now let us see what are these 3 notations: prefix, postfix, and infix notations. So in prefix notation, operator comes first. Operator comes pre means pre stands for operator. So pre stands for operator. In prefix notation, operator comes first. So this is actually postfix notation. In postfix notation, post means operator comes last. First comes the operand, and then at last come the operator. And in infix notation, in means in between. So in infix notation, operator is placed in between the operands. So you can see this is the infix notation, this is the prefix notation, and this is the postfix notation. In infix notation, operator is placed in between the operands. So A plus B. So plus is in between A and B. So same, its prefix equivalent prefix notation is given as operator comes first. So plus comes first followed by A and B. Then in postfix notation, operator comes last. So first operand A and then operand B and then operator plus. So then you can see similar infix notation for other complex expression. Suppose you want to convert this infix into the prefix. So first you need to solve the bracket. So bracket means first preference you have to give the to the bracket for the conversion. So first this expression needs to be converted into prefix notation. So A minus C. So when you convert this infix into the prefix, minus comes first. Minus comes first. So it is going to be minus AC. So it is minus AC, and then this multiplication comes last. So this multiplication is outside of this so multiplication then minus AC. So in this case it is going to be multiplication is coming out, so it is going to be multiplication BC, and this plus, so plus will come out. So plus A multiplication BC. Similarly, this in this case, first bracket expressions are converted into prefix notations, and then remaining operator is taken out. So this in this case first plus AB in this case here minus CD and this multiplication this division is then taken out. So it is going to be division plus AB minus CD. Similarly, this expression is also converted into prefix notation. So in this case, postfix notation, same way, instead of taking it before, it is taken last. So here you can see minus is taken first, so it is going to be AC minus, and then multiplication, so it is B multiplication. So whichever operator has going highest priority, that is taken out. And if there is no operator, then this parenthesis is having highest priority. Then if there are parentheses, then parentheses are solved first, means parentheses are having highest priority. If there is no parenthesis, then operator's priority is considered, and accordingly the prefix and postfix is converted. And if operator's priority is also same, if operator's priority is also same, then associativity is considered, that is left to right associativity or right to left associativity as per the associativity it is considered. Now let me explain you conversion of this expression. Suppose it is 2 plus 3 multiplied by 5 minus 4. Now in this case, the operators involved are plus, multiplication, and minus. So these three operators are involved in this. So which is having highest priority? This is having highest priority. So first this is converted into postfix. Suppose I want to convert from infix to postfix. So I want to convert from infix to postfix. So first this is converted into postfix. 2 plus 3 5 multiplication, and now this is treated as just like an operand, and minus 4. Now here there are two operators involved, plus and minus. Plus and minus, these are the two operands involved. Now here both are plus and minus are having equal priority, but plus comes first. Plus comes first. So here associativity is considered of plus and minus. So plus is associativity of the plus is left to right, and minus is also left to right. So whichever is appearing on the left is considered first for evaluation. So in this case, plus is considered for evaluation first and minus is considered for evaluation next. So in this case, this is an expression. So this is 2 is an operand and this entire is an operand. So in this case, take plus out. Now here it becomes like this: 2, 3, 5, 2, 3, 5 multiply, and this now becomes one operand. 2, 3, 5 multiply and plus. This plus is taken out. So let me erase this. So in this case, plus is taken out. So it is 2, this operand, and then next operand is 3, 5 multiplication, and after this plus is used. Now this entire becomes another operand. This entire becomes another operand, and remaining is minus 4. So this is one operand and this is another operand, and this minus is taken out. So now you can remove the bracket. So now it becomes 2, 3, 5 multiplication and plus. So now this is one operand, this is one operand, and this is another operand 4, and this is taken out minus. This is taken out minus. So now this becomes the postfix expression for this infix expression. So this is the postfix. Now suppose if it is like this: 2 plus 3 plus 8. Now if you wish to convert this into the postfix expression, now see, the operators are only plus plus, both are having equal priority. Now in this situation, what happens? First leftmost operator is considered. So leftmost operator plus is taken out first. So it is now going to become 2, 3 plus. It is now going to become 2, 3 plus, and then this 8 as it is written, and this 8 is now taken out. So now 2, 3 plus is considered as one operand. So postfix of this 2, 3 plus is done. So now it becomes 2, 3 plus, and this 8, and then plus is taken out. So when you remove the bracket, it now becomes 2, 3 plus 8 plus. Now same if you put the bracket in this. So suppose same expression, when we write it like this, 2 plus uh, 2 plus in bracket 3 plus 8. Now see how this is converted into postfix format. So remember, even though both are plus operator, first brackets are solved. So when you solve the bracket first, now it becomes like this. So this first this plus is taken out first. Now it becomes like this: 3 8 3 8 plus. Now this becomes one operand, and this now becomes 2 plus in bracket 3 8 plus. Now this plus is taken out. Now it becomes 2 3 8, this plus, and this plus is taken out. So now it becomes 283 plus plus. Now see here, when there is no parenthesis, its postfix format is 23 plus 8 plus. But when there is this parenthesis, but when you put the parenthesis over here, now its postfix changes. So it becomes like this: 2 3 8 plus plus. So what is the meaning of this postfix? So this, in this case, this plus is performed first. In this case, this 3 and 8 is performed first. So this, if it is parenthesis means this operation is done first, and followed by this plus operation is done. So at the time of evaluation of the expression, this postfix expression is useful, or prefix expression is useful. Now we are going to discuss how these postfix expressions are useful in evaluation. So that is also one of the application of this stack. Now let us consider the postfix format. Now similarly, how we converted infix to postfix. Similarly, you can convert this into infix to prefix. Now in this case, you have to scan it from here. We scan from left to right. In that situation, you have to scan it from right to left. So only scanning from right to left will make it conversion from infix to prefix. Rest all the other things remains same. Now let us see how postfix expressions are evaluated. Now consider this as a postfix expression: 2 3 8 plus plus. Now here only I will show you how these expressions are evaluated. Now consider this expression: 2 3 8 plus plus. 2 3 8 plus plus. Now go and read the character and push it onto the stack. If it is operand, if it is operator, then pop 2 operands from the stack, evaluate it, and then put the result onto the stack. Now let us see how this we can do using stack. So this is the stack. Now read this character. Now this character is digit. If it is digit, then push it onto the stack. Now this is put onto the stack. Then read the second character. Now this is also digit. 3 is also digit. Now push it onto the stack. Now read the third character. 8 is also digit. Now push it onto the stack. Now after 8, what you read is plus. Now plus is the operator. So whenever you read plus operator or any operator, what do? You pop 2 digits from the pop 2 times, perform pop operation 2 times. So when you perform pop operation 1 time, this 8 is taken in one operand. So OP1 is first operand. OP1, 8 is taken in OP1, first operand, then perform second pop. When you perform second pop operation, delete operation, 3 is removed. Now 3 is taken in second operand, that is OP2. 3 is taken in the second operand, that is OP2. And now these are the two operands, OP1 and OP2. Then perform plus operation between these two operands. So what is the result of 8 plus 3? It is going to be 11. Now put 11 into the stack. Now for that you have to remove this from the stack and then push 11 onto the stack. So this 11 is pushed onto the stack. So remember what I have done. So here it was 3 and 8. So when we read plus, 8 is taken into OP1 and 3 is taken into OP2 to our second operand, and this plus operation is performed between these two operands, and whatever result you get 11 is pushed onto the stack. Now stack contents are 2 and 11. Now third character that we read is plus. Now again do the same thing. Now whatever you perform pop first, you take it in OP1. This is taken in OP2. Sorry, this is taken in OP2. 11 is taken in OP2. In previous case also same thing. OP1 is 3 and OP2 is 8. Now 11 is taken in OP2 and 2 is taken in OP1. So let us remove this. Okay, so top is taken in OP2. So 11 is taken in OP2 and 2 is taken. So now 11 is popped and 2 is taken in OP1. Now 2 is also popped. Now what you get? 2 plus 11. 2 plus 11 is 13. So 2 plus 11 plus operation is performed because here you read plus. So 2 plus 11 is 13. So 13 is 2 plus 11. 13 is pushed back into the stack. Thirteen is pushed back into the stack. Is pushed. Now nothing is remaining. So whatever is the stack, whatever are the contents of the top of the stack. So top of the stack contents is 13. So that is the result of this expression. Now let us do same thing. So this is for this expression 2 plus 3 plus 8. So even though you do it for 2 plus 3 plus 8 or with parentheses, both are going to be same because plus is having same plus is commutative operation. So whether you evaluate 2 plus 3 first or 3 plus 8 first, so you are going to get the same result. But if it is minus, in that situation, it is going to get the different result. Now consider here it is the minus. Minus for other operands, it is going to be a different case. Now let us consider some other expression and let us do the evaluation. Now when you consider 2 plus 3 multiplied by 2, 2 plus 3 multiplied by 2, and this infix is having postfix as this is having highest priority multiplication, take it out. Now it becomes like this 2 3 2 and this multiplication is taken here first and then this plus is taken out. So remember that the whichever has got highest priority will come on the extreme left. On the extreme left operator is having highest priority. and on extreme right operator is having lowest priority. So the one having lowest priority or which is to be evaluated last, that operator will come last here. So rightmost, that is the rightmost, and the one having highest priority will be the leftmost, innermost operator. So multiplication will be evaluated first, and plus will be evaluated next. So in this situation, how it is going to be evaluated? So see here once again. So read 2. So 2 is pushed onto the stack. Read 3. 3 is pushed onto the stack because both are digit. Then again read 2. 2 is also digit. Now push it onto the stack. Then read multiplication. Now when you read multiplication, take 2 on the OP2, operand 2. So operand 2 is 2 now, and OP1 operand 1. So pop this now. So 3 is popped, 3 is taken in OP1. 3 is taken in OP1. So now what operation is to be performed here? Here multiplication is performed. So OP1 multiplied by OP2. So 3 to the 6. So here 6 is inserted into the stack. Here 6 is inserted into the stack. Six is inserted into the stack. Now next operator, next character is plus. Now this is also operator, same thing is performed. Now here this 6 is taken in OP2. 6 is taken into OP2. 6 is popped, it is taken in OP2, and 2 is popped, it is taken in OP1. 6 and 2. So it is going to be 6 and 2. So OP2 is 6 and 2. Now this is the operand plus. So plus is performed here. Here plus is performed, not multiplication, plus is performed. So it is going to be 2 plus 6. So it is going to be 8. Now see here, we perform this 3 plus 2, 3 multiplied by 2. So it's 6 plus 2, it is 8. So the evaluation of this expression, it is rather difficult to evaluate infix directly. So instead infix is converted into postfix, and then postfix is evaluated using stack. So in your calculator inside, stack is used to, so in calculator when you type this expression and press equal to, so inside first that calculator software convert that infix expression into the postfix expression, and using stack that postfix expression is evaluated. So this is again one of the important application of the stack. Now similarly, how you evaluate infix postfix expression, similarly you can evaluate prefix expression. Prefix expression, in only the difference is in postfix expression you read it from left to right, but if you are having prefix expression, so what is the prefix expression of this? The prefix is first take this multiplication out. So prefix is multiply 3 and 2, and then take this plus out. So now it is going to be plus 2 multiply 3 2. So this is the prefix. So when you do the prefix, scan it from when you do the postfix to evaluation, you scan it from left to right. Then here in this situation you do it from right to left. So in this situation you do it like this. So 3 2. So 2 push it onto the stack. Then you read 3, push it onto the stack. Then you read multiplication. So multiply 2 and 3. So what result you get? So 2 and 3 will give you 6. So result, you pop 3 and 2, multiply and push the result onto the stack. Now what remains is 2. Now push it onto the stack 2. Then after 2 it is plus. Now do the same thing. Pop 2. get it in OP2, pop 6, get it in OP1 and perform operation plus. So push addition of 6 plus 2, 8 onto the stacks. So whatever remains at last in the stack, so that is the result of this prefix expression. So whether you are given a postfix expression or whether you are given prefix expression, both can be evaluated using stack. So only it is a matter of scanning. Here you scan it from left to right, and here you scan it from right to left. So this is how postfix expression is evaluated. Now let us see how to convert from infix to postfix. How to convert infix to postfix using stack. So there also stack is used. Now for example, see here, this is an expression 3 plus in bracket 2 multiply 8. This is only given. Now you want to convert this expression into postfix expression. Now what we do here we assume that this is the opening parenthesis, this is the closing parenthesis. So first we put the opening parenthesis, even though this opening and closing is not given. When it is parenthesized expression, we assume that starting is the opening and last is the closing. So put opening parenthesis here into the stack. Okay, now see what you read. Now you read 3. Now in this situation there is a two stack. One is the operator stack. There are two stacks, operator stacks, and there is a postfix stack. Postfix. There is another one. There is a postfix stack. So this is a postfix stack. Now here, when you read this, push it into the operator stack. So this opening parenthesis is treated just like an operator. So this put it in the operator stack. Now this is the highest priority considered. And then what you read is 3. So 3 is pushed into the postfix stack. Now after 3, what you read is plus. Now push plus into the operator stack. Now again, you read the parenthesis. So push it into the operator stack. Then you see, remember, multiplication should come first in the postfix. So remember this. So this plus should come last. So in that direction we have to work out. So then 2 after opening parenthesis, then next character is 2. So 2 is pushed onto the postfix stack. Now here inside this is a multiplication. Inside this is a multiplication, and then 8, push 8 onto the stack. Then after 8, what you read is closing parenthesis. So the moment you read closing parenthesis, what you do, you delete all the characters from the operator stack. You delete all the characters from the operator stack until you get opening parenthesis and push it onto the postfix. So you remove multiplication. When you do this, the moment you read closing parenthesis. So here we read the closing parenthesis. So we remove this multiplication and put it into the postfix stack. Then again, after this, there is a opening parenthesis. So this is also removed, but it is not used here. So it is discarded. It is removed and discarded. Now after this parenthesis, now this is over now. Now you have encountered opening parenthesis. Now you have to stop. Now after that, when you read closing parenthesis, again you have to do the same thing. The moment you read the closing parenthesis, you have to go on popping this operator and push it onto this postfix stack. So remove this plus and push it onto the stack. Remove this plus and push it onto the stack. And after that, this is the closing parenthesis. So this closing parenthesis first gets balanced with this last this first opening parenthesis gets balanced with this closing parenthesis. So this is only removed from the stack and it is not at all used. So what you get in the postfix is the postfix expression when you read from bottom to top. So when you write this expression 3, 2, 8 and multiplication and plus. So you get the postfix equivalent to this. So see here, first we remove multiplication and then we remove plus. So first multiplication is removed and then plus is removed. Now when there is no parenthesis, let us consider another example. Now let us assume without parenthesis case. So now here you are given 2 multiplied by 3 plus 8 multiplied by 4. Here you consider multiplication and here you consider plus. Suppose you want to evaluate this. Now, what is the postfix of this? The postfix of this is first multiplications are taken out because they are having highest priority. But we have 2 multiplication. But in this 2 multiplication, we take out this leftmost first. So it is now going to become 2, 3 multiply. Then 8. Then this multiplication is taken out. And then after that, this 4 is written. And lastly, plus is taken out. So this is the end postfix expression. Now we want to obtain this. So how we can obtain this using stack? Now same way, there are 2 stacks. So we assume that here it is the opening parenthesis and here there is a closing parenthesis. Now first we put the opening parenthesis here. Then this is the operator stack. This is the operator stack and this is postfix stack. This is postfix stacks. Now here you read 2. 2, it is not a operator, so push it onto the postfix stack. Now after that you read multiplication. Now you put that into the operator stack. Now after multiplication you read 3, you put it into the postfix stack. Now after 3 you read multiplication. Now here what you want here after 2 and 3, you want here multiplication, right? So now you see the priority of this multiplication and the priority of this multiplication. Now both are having same priority, but which multiplication has come first? This multiplication has come first. So because this multiplication has been pushed onto the stack. So this multiplication is having highest priority than this multiplication. So when you read multiplication, when you read any operator and the priority of this operator, top of the stack operator is more than the priority of this operator. Now this is also multiplication and this is also multiplication, but this multiplication priority is more than this multiplication because this multiplication has come on the left. So in that situation, what you do, you pop this multiplication. You pop this multiplication and put here. Pop this multiplication and push it over here in postfix stack. Now after that, this becomes empty. So that priority checking is done. Now after that, this multiplication is compared with opening parenthesis. Now opening parenthesis is always having a less priority than multiplication. In that situation, what you do is push this multiplication on the top on this operator stack. So push this multiplication on the stack. Now after this multiplication, what you get is 8. So 8 straight away push it onto the postfix stack. After 8, what you read is plus. Now again, plus is the current operator. Plus is current operator, and this multiplication on the top of the stack, there is a multiplication. So straight away multiplication is having highest priority than plus. So whenever there is a operator having highest priority than plus, remove it and push it onto the stack. So this multiplication is removed and pushed onto the stack. See here, we are getting close to this. So 2, 3 multiplying, 2, 3 multiply, 8, 8, this multiply, and then after removing this multiply and putting here, then next, so what we do with plus? Now you put plus here. After removing this multiplication and pushing it in the postfix stack, now push plus here. After pushing plus here, we read next 4. So 4 is the operand. So 4 is pushed onto the postfix stack. Now here after 4, what we read is closing parenthesis. Now when we read the closing parenthesis, what we do, we remove all the operators from the operator stack. So we remove all the operators from the operator stack, that is plus. Now here plus is removed and plus is pushed onto the postfix stack. And until you read opening parenthesis, do these things. So plus is removed and it is pushed onto the stack. Now what you get here at last is postfix expression. So this is how infix is converted into postfix expression using stack. So the algorithm is given over here, and one expression example is also given. So algorithm to that effect is C. This is the algorithm for evaluation of the postfix expression. Whatever we have seen, it is given in the form of algorithmic steps. So you can refer this algorithm for exam and prepare this algorithm accordingly, and you have to work out with the help of example. Now this is evaluation of prefix expression. Now what we have seen so far is the evaluation of the postfix expression. Same thing, you can do it for evaluation of the prefix expression. Now this is the algorithm to convert infix to postfix. Just now whatever steps I have shown you, same steps are mentioned over here. So first push this opening parenthesis, then add this to the end of the string and so on. So scan left to right. So same steps are repeatedly performed over here. And then next algorithm is for evaluation of the postfix expression. That is already we have seen, and this is the evaluation of prefix expression, and this is conversion of infix to postfix. So you can see this example is given over here. So this is the postfix stack and this is the postfix expression. Both are stack. And initially you read A. So initially opening parenthesis is put into the stack. Then you read A. A is pushed into the postfix expression. Then plus is put into the stack. Then next symbol is opening parenthesis. Then it is pushed onto the stack. And then B is pushed onto the postfix. Then multiplication, it is pushed onto the stack. Same thing, whatever we discuss right now, same thing is demonstrated with the help of this table for this expression. Now in this exam, if this expression is asked to be converted into postfix format using stack, and if you are asked to show the step-by-step explanation, then you have to draw this table and show this symbol, number, and scan the symbol and position of the stack and contents of postfix stack expression and what action is done. So it is given over here. So this table you have to draw. Okay, so that's all for the today. So today we have seen all the applications of the stack. So we have discussed palindrome application of the stack, palindrome checking, then backward backtracking application of the stack. Then we have seen how to evaluate prefix expression, then how to evaluate postfix expression using stack, and then how to convert infix to postfix using stack. Similarly, you can convert infix to prefix, but in that case you have to scan it from, you have to read it from right to left. Only that is the change. So now I request all of you to write what are the today's lecture key takeaways.